How are you guys doing today? So today we're going to be learning about linear probabilistic modeling. So what is linear probabilistic modeling? Linear probabilistic modeling is a technique that estimates the probability of binary outcomes through linear regression. In simplest terms, when there's a situation that can only result in two outcomes, we can use linear probabilistic modeling to estimate the likeliness of the outcomes happening given an independent variable. Since linear probabilistic modeling uses linear regression to make a probability model, for this example, I plotted random points and each point has been given a certain amount of error. From here, I've drawn a line of best fit. The linear regression formula tells us that the random error variable epsilon allows for data points to fall below and above the line of best fit. As you can see from the graph, the points that lie above the line of best fit tells us that epsilon is greater than 0. The points that lie below the line of best fit tells us that epsilon is less than 0. And the points that lie just right on the line of best fit tell us that epsilon is exactly 0. We can see that in the unique case of linear probabilistic modeling, the expected values of y range from about 0 to 1. So, let's say we were given a task in our engineering field to spot the correlation between the temperature and the success and failure rate when manufacturing CPU models. Here's a distribution of success and failure rate in the manufacturing process. Now you might notice that near the maximum interval 1 and the minimum interval 0, that there are some integers that are closely bunched. You could use this as an indicator to show how the independent and dependent variables are interacting with each other at a given time. Now the flaw that comes with using linear probabilistic modeling can be seen near the end of the graph. Probability law states that probability be contained within the interval from 0 to 1. But as you can see, we can actually produce probability under and over 0 and 1, which can cause our data to be inaccurate. Another flaw with linear probabilistic modeling is the non-normality of the error term, and that the error term is normally distributed. But the error term cannot be normally distributed because it can only yield two possibilities, y equals 1 and y equals 0. Thank you for joining me on my briefing about linear probabilistic modeling. I hope my briefing gave you a better understanding on the topic and that you came out knowing a lot more than you did when you first came in. On any case, thank you for watching and have a good day.